So you just hooked up a shiny new foundation model to your company's website. It feels like a massive win, right? But then you ask it a standard question about your actual products, and the answer it spits out is, well, incredibly generic. Why does a cutting-edge AI chatbot sound like it has absolutely no idea what your business actually does?
Welcome to this explainer. Today, we're going to figure out how to climb the generative AI maturity scale together. We're drawing our insights specifically from chapters 10 through 12 of the source material. That's pages 249 to 334 for those keeping track. We'll be focusing heavily on the advanced stages, taking Amazon Bedrock models from basic, out-of-the-box setups and transforming them into genius-level, highly customized enterprise solutions.
Here's our roadmap for today. 1. Customizing your AI model. 2. Choosing a customization strategy. 3. Evaluating model performance. And 4. The cost, quality, latency triangle.
Let's jump right into Section 1, Customizing Your AI Model, featuring the AnyFinTech case study.
Let's look at a fictional company called AnyFinTech. Now, they were super excited to launch their bot, but the initial user feedback? Yeah, it was terrible. When a user typed a totally standard intent like, "I would like to activate a card," the foundation model gave a technically correct but completely unhelpful response. It just said, "You can also activate your card through the mobile app." It completely lacks any fintech's specific brand guidelines. It's vague, it's robotic, and honestly, it's just not a great customer experience.
But look at the difference when that exact same model is customized. The same prompt now yields precise, step-by-step instructions. It tells the user exactly how to locate the instructions, visit the issuer's page, and enter their specific security code. It suddenly sounds like an expert employee. This right here is why customization matters so much. It protects and projects your actual brand identity.
Okay, Section 2, Choosing a Customization Strategy. We're looking at fine-tuning versus continuous pre-training. So how do we actually pull this off? Our first strategy is fine-tuning. The goal here is to specialize a model for a specific task. But as you know, training billions of parameters from scratch is insanely expensive. That is where LoRA comes in, low-rank adaptation. Think of it like a cheat code for efficiency. Instead of retraining the whole brain of the model, LoRA modifies only a tiny, targeted subset of parameters. This allows developers to affordably fine-tune models on Amazon Bedrock without racking up massive compute costs. It's a real game changer.
But wait, what if the problem isn't just the tone or the style? What if your AI literally just doesn't know the facts? Take a look at our second fictional case. Any marketing analyst. A user asks the bot about Amazon's operating income in 2024. The model fails. It confidently spits out data from 2023 because its underlying knowledge base is just stuck in the past. And here's the thing. Fine-tuning won't fix a fundamental lack of world knowledge.
To fix the specific issue, we have to use continuous pre-training. This technique uses massive, diverse data sets to actually update the model's fundamental understanding of the world. After continuous pre-training, the Any Marketing Analyst chatbot flawlessly provides the up-to-date 2024 operating income, correctly noting the massive growth to over $60 billion.
So this gives us a really clear decision framework. If you have limited labeled data and just need your bot to follow specific stylistic instructions, you want fine-tuning. It's targeted and it's cost-effective. But if you need to teach the model entirely new facts, new concepts, or recent global events, you're going to need continuous pre-training. Now, it requires abundant data and is definitely less economical, but it fundamentally expands the model's brain.
Moving right along to Section 3, Evaluating Model Performance to Ensure Reliability.
Look, customizing a model is incredibly powerful, but you absolutely cannot just push it to production and cross your fingers. Safety is non-negotiable. You need rigorous automated evaluation metrics in place. We're talking about testing for accuracy. Is it hallucinating facts? Robustness. Does it break easily when users try weird prompts? And toxicity. Metrics like the Delta Classification Accuracy Score help you mathematically prove that your newly customized model is actually performing better and safer than the base model it started as.
But here's the tricky part about generative AI. It generates human-like text, and traditional math doesn't always capture the nuances of human language. That leads us to a really fascinating solution known as LLM as a judge. Because LLMs understand context so well, you can actually prompt one AI to act as an impartial judge for another AI. It can evaluate subjective traits like logical coherence, faithfulness to the source material, and overall relevance. It's kind of wild when you think about it, using AI to grade AI. Finally, Section 4, the cost-quality-latency triangle, the ultimate balancing act.
So you've customized your model, you've evaluated it for safety, and now it's time to deploy. Every single enterprise architect has to juggle the three interconnected pillars of generative AI. Cost, how much you're paying for compute power. Quality, the accuracy and richness of the response. And latency, how fast the user actually gets their answer.
You really have to visualize this as a strict triangle. You literally cannot pull one lever without fundamentally impacting the other two. Think about it. If you aggressively decrease your cost by using a smaller model, your quality is almost certainly going to drop if you want to maintain fast latency. Conversely, if you demand blazing fast speeds but absolutely refuse to sacrifice quality, well, your compute costs are going to skyrocket. It is a constant, everyday trade-off.
And that balancing act dictates your entire AI workflow roadmap. You always want to start simple. Begin with in-context learning, basically just writing better prompts. If the quality still isn't there, step up the complexity to RAG. If it's still not smart enough, then you move to fine-tuning, or eventually all the way to continuous pre-training. And notice the constant loop here. Model outcome evaluation has to happen at every single step so you can objectively measure if the increase in cost is actually giving you better quality.
To manage that latency without sacrificing quality at scale, you might eventually graduate to advanced architectural workflows like parallelization. Picture this: a prompt comes in, and a decision router actually invokes multiple foundation models at the exact same time. It runs parallel evaluations, and then a decision aggregator combines the very best parts into one final, polished outcome. Yes, it costs a bit more, but for complex, high-stakes tasks, it maximizes both speed and quality beautifully. Which brings us to the end of our explainer. I want to leave you with a question to seriously consider for your own organizational AI projects. When push comes to shove, which corner of that triangle are you willing to compromise on? Because finding your specific balance between cost, quality, and latency, that is the true secret to mastering generative AI. Thanks for exploring this with me today.